Alright, here's the 2-page homework practice sheet, practicing those concepts of knowing the parent and transforming the parent. So here, the indicator is that cube, so the parent is x cubed. I think it is helpful to write down the parent points and transform them. That would be 0, 0, 1, 1, maybe 2, 8 if it fits. Definitely -1, -1, and maybe -2, -8. So I'm just cubing the numbers right around 0. I can tell that it's going to go to the left 1, 3. The 2 is a vertical stretch. The -5 is a vertical shift. So that's what's going to happen. Left 1, down 5, and it's going to be stretched by 2. So let's see what we get. And if it doesn't fit on our graph, I'm just going to avoid it. So 0, 0, the x, I do the inverse of what it says. So I'm going to subtract 1. To the y's, I'm going to do two things. I'm going to multiply times 2, take that answer, and subtract 5. So 0 times 2 is 0, and then subtract 5. 1 times 2, take away 5. 8 times 2 is 16, take away 5. -1 times 2, take away 5. This one's for sure is not going to be on my graph. -8 times 2 is -16, take away 5, -21. So, plot the ones I can. So 0, 0 becomes -1, -5. There it is. That's our point of inflection, so that's why it's important to put it down first. So going up to the right, we have 0 and -3, and we have 1 and 11. So I'll just squeak it out there above. So I know this is the direction it smiles, going up to the right. Then I got -2, -7. And this will not fit obviously on my graph at all, but I can see what direction it's going to go. So it's going to frown and then smile. The domain and the range is all real numbers. The x-intercept, for that one I'd have to make it equal to 0 to see it. So to make it equal to 0, and then can you do the steps that follow to get x by itself? So you would add 5, divide by 2, take the cube root, and then subtract 1, just that little journey going backwards. So add 5, divide by 2, cube root it, and then you would subtract 1. You can approximate what it is. You can see it's between 0 and 1. The y-intercept is a lot easier. It's right there. It's at -3. Extreme points. We don't have any extreme points. We do have a critical point. So I'll put down the critical point. The critical point is that point of inflection, which is at -1, -5. Where is it increasing? Everywhere. Where is it decreasing? Nowhere. So when I look left to right, what's the end behavior? Well, as x approaches infinity, f at x is approaching infinity. As x approaches -infinity, that's the left end, the function's going to -infinity. All right, number 2. The parent is just the square root of x. I'm going to write down the parent points, 0, 0, 1, 1, and the square root of 4 is 2. That's good enough. When I look outside, that's what affects the y-coordinate. It's a stretch at 2.5. So just the y's, I'm going to multiply by 2.5. That's 0. 2.5 is 2.5. And then 2 times 2.5, like doubling 2.5, and you get 5. to the x-coordinate, two things are happening. So you can see the negative and the adding 6. We're going to go in that order. So divide by -1, add 6, or change the sign and add 6 is fine too. 0 doesn't have a sign to change, add 6, and there it is. This becomes -1, and add 6 becomes 5. 4 becomes -4 plus 6, and that's 2. So now we have the points we need. So 6, 0. We have 5 and 2.5. We have 2 and 5. And there's our curve, like a parabola on its side, a half a parabola curving up on its side. So there's what it looks like. Notice the negative inside made it reflect over the y-axis, so now it's pointing left instead of right. The domain comes from that endpoint. So if you look and see what's the left and the right, so for the x's, it goes from -infinity and what that x value there of the starting point is, which is 6. And 6 is included. The range, bottom to top, so it's 0. 0 is included, and it goes to infinity. X-intercept, it's right there, which is nice, which is 6. The y-intercept up here, we can approximate it, but if I wanted to know the answer, I'd plug in 0 for x, and then you have a negative times a negative. So the exact answer, I don't know the square root of 6, so it would just be 5 root 2 times the square root of 6. I mean, I know it, I can approximate the square root of 6, but I don't know it exactly. There's no extreme values. There's nothing that's increasing. Instead, it's decreasing from -infinity all the way to what that x value is, 6. I guess down here you could call that -6, 0, the absolute minimum. You could call that an extreme value. It's the lowest point on the graph. And behavior, I mean, as x approaches -infinity, the function is going to +infinity. As x approaches 6, then the function approaches 0. I guess you could do that as well. Number 3. So, what kind of function is number 3? What's the indicator? So I see the bars, so the parent is just the absolute value of x. I think it looks like a V, right? This negative is going to make the V reflect down. And then inside I have two things. So that 1/3 will actually be a horizontal stretch because it's the inverse. And then the +3, I do the inverse, it's going 3 to the left. So the x's change a little bit. It's going to make it look a little wider and move to the left 3. So some parent points, and then I'll reflect over the axis of symmetry. So I know the y's, I'm going to change the sign, or times -1. 0 won't change. +1 becomes -1. +2 becomes -2. To the x's, there are two things. So instead of 1/3, it becomes times 3. Instead of adding 3, it becomes subtracting 3. So we're going to go times 3 and then subtract 3. So 0 times 3 is 0, and then subtract 3. 1 times 3 is 3, subtract 3 is 0. 2 times 3 is 6, and subtract 3 is 3. So I'm going to put those points down and use the axis of symmetry. Now I know it looks like a V. So -3, 0, 0, -1, and then the axis of symmetry here gives me another point. So there's the axis of symmetry. So I count to left the same number. So they're the same distance from the line. 3, -2. And then same distance from the line, so 6. And then you can see it's a V that's widened out. The domain is all real numbers. The range, the bottom of the range is -infinity, but the top, it has a ceiling, and it's 0, and it's included. The x-intercept's right there, what I circled, which is at negative 3, 0. The y-intercept's over here to the right. Where does it cross the y-axis? Is at 0, negative 1. We have one extreme point. We have an absolute max at the vertex, which is at negative 3, 0. Where is it increasing, left to right? So from negative infinity to negative 3, it's increasing. From negative 3 to infinity, it's decreasing. So it increases and then decreases. End behavior, as x approaches infinity, the function approaches negative infinity. As x approaches negative infinity, which is the left end behavior, the function approaches negative infinity. So that's a fancy way of saying the right end and the left end are going down. All right, turn the page. All right, understand the parent function. So it's a parabola. It's x squared. What are some parent points? 0, 0, 1, 1. And then 2, if you square 2, it's 4. That's good. I can see inside, we're going to shift to the right 5. That's it. So I'm going to add 5. To the y, I got 3 things happening, and one of those things I'm going to tie together. So the negative, the 1/2, and the negative 3. So the negative is going to make the parabola fold down. It's reflecting down. 1/2 flattens out the parabola, so there's a vertical compression. So it's going to look wider. And then the subtract 3 means everything shifted down 3. Those are the transformations. So we're going to go 0 times negative 1/2, which is 0, and then subtract 3. So there's a vertex. 1 times negative 1/2 is negative 1/2, and then subtract 3 is negative 3 1/2. 4 times negative 1/2 is negative 2. Take away 3 is negative 5. So we can use the axis of symmetry to find more points as we need them. So 5, negative 3. 6 and negative 3 1/2 reflect over. 7 and negative 5 and reflect over. So there's your parabola. What's the domain of it? It's all real numbers. The range, so that goes from the bottom, which is negative infinity, to the vertex in the y-coordinate there is negative 3, and it's included. X-intercepts, none. It doesn't cross the x-axis. The y, it will eventually cross the y. So if I plug in 0 for x, I get 25 divided by 2, so it's 12.5. So negative 12.5 and negative 3 is negative 15.5. Extreme, we have one extreme point. It's an absolute max. And that's at 5 and negative 3. So the maximum value of the function is negative 3. It increases from negative infinity to 5. And then from 5 to infinity, it decreases. The end behavior, as x approaches infinity, the function approaches negative infinity. As x approaches negative infinity, the function approaches negative infinity. Again, a fancy way of saying the right end goes down and the left end goes down. All right, number 5. Parent function, cube root of x. So transformations, I'm first going to start with some parent points, 0, 0, 1, 1. In this case, when you plug in 8, you get the answer 2. We also have negative 1, and negative 8, negative 2. So those are the numbers you can take cube roots of. So inside, I see negative 2. So that's going to be a reflection over the y-axis. And the 2, we're actually going to go divide it by 2. So it's a half. So it's going to be a horizontal compression. So it's going to be pushed in a little bit. And then the 3 is a vertical stretch. And the plus 1 means everything's going up 1. So let's change the points. So the x, divide by negative 2. That's 0. That's negative 1/2. And that's negative 4. This one would be positive 1/2, and this one would be positive 4. To the y's, Multiply it times 3 and add 1. So 3 times 1 plus 1 is 4. 2 times 3 is 6. Plus 1 is 7. Negative 1 times 3 is negative 3. Plus 1 is negative 2. That's negative 6. Plus 1 is negative 5. Plot the points. So I can tell going this way what's happening. The other points, 1/2 and negative 2, and then 4 and negative 5. So you can see the direction and how it's been stretched and compressed. The domain and range are all real numbers. To find the x-intercept, you'd make it equal to 0. It's actually the cube root of negative 1/3 divided by negative 2, which is somewhere between 0 and 1. Very close to 0. The y-intercept's a little bit easier. Plug in 0 and you get the answer 1. And we have that, 0, 1. Extreme, no, but we do have a point of inflection, and that's at 0, 1. Increasing, nowhere. Decreasing, everywhere. And the end behavior, as x approaches infinity, the function approaches negative infinity. As the x approaches negative infinity, the function approaches positive infinity. Done. Number 6, last one of this type. What is the parent? It's the reciprocal, or the rational function 1 over x. So I'm just going to use the points 1, 1, and negative 1, negative 1, and the two asymptotes x equals 0 and y equals 0. What's in the denominator affects x. So I'm going to add 4, because it moves 4 to the right. That also affects the asymptote. The y, it's the numerator and what's outside, so negative 1 times 1 plus 3. Negative times a negative plus 3. And then 0 times negative 1 and then add 3. So that's what I'm going to plot. So x equals 4. Maybe I'll use my green color for that. Y equals 3. We have 5 and 2. And we have 3 and 4. So understand what's below. At the vertical asymptote, it goes down forever because it's underneath that horizontal asymptote. And then as it goes up, it's going to follow the horizontal. That's the end behavior. The point that's above, at the vertical asymptote, it goes to infinity. And then to the left, it follows the horizontal asymptote. The domain is all real numbers, but the only number x can't be is 4. That's where the asymptote is. The range, same thing, all real numbers, but the only number y can't be is 3. The x-intercept, where does it cross? It's right there. So if I make it equal to 0 and I solve for x, you would subtract 3. I would do the reciprocal, so it's negative 1/3, positive 1/3, add 4, 4 and 1/3. So at 4 and 1/3, it crosses the x-axis. The y-intercept, plug in 0 for x. A negative divided by a negative is positive, so it's 3 and 1/4. So you have 1/4 plus 3, make it easy. Extreme values, none. Increasing, everywhere. So the only part that's not increasing, we have to include the asymptote, which is at 4. So this means that 4 is not included. So from negative infinity to 4 and 4 to infinity, but 4 is not included. Decreasing, nowhere. The end behavior, As x approaches infinity, the function approaches a constant, the horizontal asymptote, which is 3. Same thing for the left. So both left and right hand approach 3. All right, there it is. Good practice. Understanding the parent and how to transform it, and graphing, and not being intimidated by graphing, but practicing until you get better. I'm really proud of you. Mr. G. Bath, over and out.